Today we're going to be solving inequalities. Now, we've solved equations over the last several weeks, and we came up with several steps we came to follow. We will follow the same rules just as we did with those. The only difference is they're going to be an inequality compared to an equation. If we see a set of parentheses, guess what we need to do? We're going to distribute. If we see terms on the same side of the equal sign, we're going to combine them. We're just going to add them up. Okay? Third step, once we can't combine any more like terms, we want to collect variables on one side. So if you have variables on the left-hand side and on the right-hand side, which is the opposite, we need to add opposite variables. And we're going to add the variables. Then, once you get the variables on one side, we want to get the plain numbers on the other side. Again, we're going to add opposites in the plain numbers. And then finally, we're going to multiply by the reciprocal or divide by that number, depending on what the problem looks like. So as you can see, you remember all these different steps. We've talked about them quite a bit. We're going to use the exact same steps. If you need to copy them down again, pause the video and copy these down, because we're going to be using these over the next few weeks. So what does this look like? So let's say, and we're going to start easy, and we're going to see problems like this. Here's our first problem. X minus 15 equals a negative 12. Let's drop it down here. X minus 15 equals negative 12, so it's not net light. All right? So, once again, we identify where our variable is. And we don't want equals. We want an inequality. We want greater than. Let's throw a greater than sign in there. So we want to get this x by itself. Now, we look at this. Again, this is a negative 15. You can think about it as a plus a negative 15. Once we can't combine any like terms. The only thing we can do is add opposites. The opposite of a negative 15 is a positive 15. So we carry down the x, we carry down that greater than sign, and now we have negative 12 plus 15 is a positive 3. And we're done, just like it was if it was an equal sign. Now the only thing we do have to add in, we do want to graph this. So say 0's in the middle, here's 3, 1, 2, 3, 4, 5, there's a negative 1, negative 2 over here. So greater than are numbers bigger than 3. So I know I'm going to be putting a point right here on 3. And because it's just greater and it does not include it, it is an open circle, and we would shade to the right. This meaning all these numbers that are bigger than 3 will make this true. Whether it's a 4, 5, 6, 7, 8, or 9, all of those make that true. Here's letter B. It is 7 plus x. Whoops. Is less than or equal to negative 4. Again, we have x on the left-hand side. Remember how we draw the line down the middle? All right? We want to get this x by itself. We have 7 plus x. So what's the opposite of 7? A negative 7. So we're going to add negative 7 to both sides. And we're left with x less than or equal to negative 11. When we graph this, Okay? Here's negative 11 here. Now we want numbers that are less than or equal to. So to start with, less than or equal to will be a closed circle on negative 11. And what numbers are smaller than negative 11? And again, these are all negative numbers. But think about it. Is 0 over here less than negative 11, or is this greater than? Or positive numbers. These numbers over here are positive. These are greater than. So we don't want to include these. Remember, all numbers going to the left are smaller than negative 11. So in this case, this graph would be going to the left. So there's the first two problems. We're going to go over two more problems. And I'll give you a couple minutes to start letter C. We have 10 greater than or equal to x plus 3. So you can start working on that one. Think about what you have to do. How are we going to get x by itself? Now, as you can see, this time, the x is on the right-hand side. Keep that in mind when we go to graph. But we see that we're adding 3 to x. So what's the opposite of a 3? A negative 3. So we're going to add negative 3 to both sides. And now we're going to get 7 greater than or equal to x. Now, hopefully, you recognize something. The x is on the wrong side. This is going to make it a little more difficult, and we have to think a little bit more about writing or graphing this. So instead of writing this as 7 greater than or equal to x, we're going to flip-flop it and make it x less than or equal to 7. Now, this will help us graph this problem. 7's there. 8, 9, 6, 5, and so forth. So again, less than or equal to, closed circle. And numbers smaller than 7 are 4, 5, 6, so we're going to shade to the left. So it's all these numbers here going forever to the left-hand side. So again, remember the flip-flop here. And here's our last one. Again, we have the line going down the middle. Opposite of a positive 8 is a negative 8. So we are left with P. 5 and a negative 8 is a negative 3. When we graph this, think about open circle or closed circle on P, or on negative 3 here. This will be an open circle. And numbers less than negative 3 are going to the left. Less than means going to the left. Keep these problems in mind. This is just the first step of this. We will be adding stuff throughout. But remember, if something's being added or subtracted to the x, to the variable, we're going to start by adding the opposites. Okay? Actually, this would actually be our last step if we had a long list in order. See you next time.